Welcome and hello. This is a video tutorial in HEC RAS, and in this lesson, I'm going to be discussing the Flow Hydrograph Optimization feature. All right, this is a tool in the Unsteady Flow Analysis dialog box that will match a user-specified stage or flow at some location in the model by scaling up or down a user-specified starting flow hydrograph. All right, well, that's what I understand it to be. So I will leave a link to the user's manual right here to this page where it discusses this topic, flow hydrograph optimization. But in this video, I'll describe how that works. All right, what I have on the screen here is my HEC RAS. I've got a river station 100,000 that goes down to river station 0 in my one and only river reach. I've already ran the model and tested it. And what I want to do is go to the run unsteady flow analysis. And then what we're going to do here is click on options and then automated flow optimization. So by default, this will not be checked, but I've already checked it on because I've been preparing for this lesson. But when you click this value right here, you'll get a new dialog box and it's going to actually start off with the value of none for flow optimization mode. And when it's turned off like this, then your simulation will run just as normal. But if you have it turned off, either stage or flow, then your simulation is going to use the base case from your data input and then try to match the target data specified down below. So if I click OK and then options, now you see it's checked off, automated flow optimization. Okay, so I'm going to first run my model with it checked off just to show you what the base case looks like. Then we'll return to this feature, toggle it on, describe the parameters, and then run it, and then you'll be able to see the difference. All right, so let's go ahead and check out the data. What I'm going to do is run a unsteady flow hydrograph, route it through the top of the reach at this river station 100,000. And then what that flow looks like right here, it basically just ranges from 800 CFS up to 1200 CFS, and then back down, up, down again. So let's go ahead and run that. Click OK, close that, and then run unsteady flow analysis. This is a 3-day simulation on a 1-hour time interval. The computation interval is 1 minute, so all pretty standard stuff there. The simulation ran. I'm going to click close. To look at the results, I'm going to click on view, and let's look at the stage and flow hydrographs. Okay, let me resize this real quick. Here we have river station 100,000, and of course the flow rate looks exactly like the boundary condition because this is the top of the reach. But if I select river station 0, which is at the bottom of the reach, we actually have some different data. Now the flow doesn't peak at 1200, it actually peaks at 1184. Let's go ahead and get the numbers exactly. So view, profile summary table, and here we go. So the peak flow at river station 100,000 is 1200 exactly. And then downstream, due to some attenuation, we have a peak flow of 1189. So what I want to do in this lesson is use the flow hydrograph optimization tool to set a target at this river station 0. And I want the max flow rate at river station 0 to be 1200. And I'm curious, what flow rate do I have to actually send through at the top of the reach at river station 100,000? So this tool for flow optimization is sort of a reverse search. Instead of the normal way of running the model where the user provides the model, the input data, runs it, and looks at the results, this tool works backwards where the user specifies what results they want to see. Specifically, I want exactly 1200 CFS here at the downstream end of the reach. And then it's up to HEC RAS to generate the peak flow. And what it's going to do is it's going to create a ratio. And you can tell right now the ratio is probably going to be like 1.01 or 1.02. It's going to scale up this 1200 max flow just a little bit so that it becomes 1200 down here at river station 0. Okay, enough talking. Let's get to the parameter data. So I'm going to click on options, automated flow optimization, and let's go ahead and toggle it on. So we're going to select flow because what we want to do here is match the flow down at river station 0. When I select flow from this drop-down box, then further down I have a target value and a tolerance whose units are in CFS and fraction. Now you're going to have all blank values the first time you set this up. I think most of the values are blank. I think the tolerance value might be set. But just so you know, some of these values I've already entered myself. Secondly, if you select stage, so for instance, you want the stage at river station 0 or somewhere else in your model to be specified, then you'd still set a target and a tolerance, but instead of CFS and percent, it's just going to be in the units of length, in this case, feet. Okay, so I'm going to stick with flow. Now the reference location, this threw me off a little bit. I thought I could just check any cross section, but what it is it's actually a reference line. So I'm going to select reference line at river station 0. This was a feature I had to go into the geometry editor to add. So I'm going to show you how to do that right now. There's also a way to do this in HEC RAS mapper, apparently, according to the user's manual. But right now I'm going through the user's manual for 1D steady and unsteady flow. So it doesn't have any discussion on RAS mapper. All right, so I'll show you how to do this in the geometric data editor. I'll just go ahead and close this momentarily. Right now I have this reference line already sketched in here at river station 0. And say I want to add another reference line. What I'm going to do is come up to this reference lines right here, click it, and then just drag across the reach. I believe that's how it's done. So a single left click to start it, and then drag across and double click. Yep. And then I'll give it a name. Reference line at river station 5. I don't know exactly what station this is, so I'm just making this up. Not going to use it anyway, but I'll click OK. There's my reference line. And now I can select this reference line or this reference line when I go back to my unsteady flow analysis, options, automated flow optimization. Now for the reference line, I can select either of the two reference lines that I have on the map. All right, probably doesn't make too much difference. They're so close together. I'll just go ahead and select the original one though at river station 0. As I mentioned before, I want that target value at river station 0 to be 1200 CFS. And then the tolerance I'm going to set to 0.001. I had to play with this tolerance a little bit. For instance, if it was too high, then the model would converge at a value that's way different than 1200. So this is something you have to play with a little bit. The initial flow ratio right here, if you don't know what to expect, you can just set it at 1, or if you expect your answer to be close to 1, you can set it to 1. But what it is it's going to be a ratio or a fraction of your original data. So if I set this up to, say, 2400, then I may as well start this at 2 because I know the answer is 2 or probably close to maybe a little bit more. And I know that the original data peaks at 1200, so that the target value of 2400, yeah, would be close to 2. All right, let me change that back though. The minimum flow ratio and maximum flow ratio are pretty straightforward. It basically means the optimization should not search less than half or more than double. You can change these values as needed, but I'm just going to go with that. And then the maximum number of trials right here. This is basically a stopping criterion. For instance, if the calculated error between computed and the target value right here exceeds the tolerance, which is right here, then a new iteration will run. If it doesn't, then it'll stop. However, it'll also stop if you already hit the maximum number of trials. Flow hydrographs to scale right here. I'm just going to say all flow hydrographs because I only have one anyway. But if you had multiple, you could select this, select the flow hydrographs, and then restart approach. When I was playing around with this, I had some trouble with the first option. This uses initial conditions specified by the user from the unmodified flow hydrograph, and apparently it's more stable. But I had better luck with the recompute each trial. So, maybe I could try that again sometime, but I'm going to go with recompute each trial. This uses scaled hydrographs to establish initial conditions. All right, without further ado, I'm going to click OK and then File, going to save. Notice that there is a little message down here to say that the automated flow ratio optimization is invoked. So let's go ahead and click Compute. Now we're seeing some optimization trial data list out here. Okay, it computed and it looks successful. I'm going to scroll up though to show that data. Okay, so this looks successful. The first trial was the initial trial, which we already ran, where we have a difference of 11 CFS. The target is 1200, and then the actual flow amount is 1198. So we knew that. Since the computed amount was less, it's going to next time use a ratio that's larger than 1, because here's ratio 1 for the first trial. So it did that. It said 5% larger. That resulted in a difference of being over by 49, because it's 1249 and the target's 1200. And then on the third and what looks like final trial here, we have a ratio of 1.009. That resulted in a downstream flow of 1200 exactly. which matches the target, and that satisfies the tolerance. So we only needed 3 trials. We set the maximum to 10, didn't need it. So that's pretty cool. Good search. Let's go ahead and take a look at those results now. So I'm going to close that. I'm going to go up to view, and then let's take a look at stage and flow hydrographs. Now, right here, it started me off at 100,000 River Station, which is actually not a bad place to start. See, we see the max flow is now 1,208, and then the second one is a little bit lower anyway. So we had to send 8 CFS through, a little bit more than 1,200. Now let's go back down to River Station 0, and the peak here should be exactly 1,200. Okay, so the graph, I can't quite get it right, but let's take a look at the table data. So go View, Profile Summary Table. Now this profile is maximum water surface elevation. So here is my answer. We have 1,200.01. That is within tolerance, so that's good. And then at the top of the reach, we had to send out a peak of 1,210.83. And that's referring to the flow rate in units of CFS. Well, that's it for this lesson. We created a river reach and we specified a target flow at a downstream location and then ran this tool for the flow hydrograph optimization to determine what sort of input was required to match our desired outcome. I will say that this model right here, right click, full plot, is a little bit oversimplified and probably not really that satisfying. But you can imagine if your system was a lot more complicated with storage areas, 2D flow areas, lateral structures, that this particular tool would be really helpful for finding out what sort of input data led to what sorts of results.